All right, let's go through Chapter 9. And Chapter 9 is data design. And we're going to talk about files, file-oriented systems, different data design terminology, and data relationships. A certain level of familiarity with databases is beneficial when going into this chapter. So, the information that we're dealing with information systems, right? So information, how do we get information? Data is manipulated and put into a specific context. That becomes information. So if I said, here I've got this number, 8675309. Doesn't mean anything to anybody until it's put into a specific context, and then it becomes a phone number. And some of you may recognize it from a song. And that differentiates that number from meaning nothing to anybody and just being raw data to being information. They said, what is the phone number? 8675309. That's information. Okay. So with that said, we want to maintain this data in a certain way. Okay. We've got a file storage system, and we want to have this data stored in our database. That's our files, our storage for data. The different platforms we could use: Microsoft Access, MySQL, Oracle, SQL Server. So there's different types of databases that we could use to store our data. Data's stored in records. Each record will have a number of different fields. Now the record is information that's being collected about a specific entity or object. Let's say a student, or in the example that I've got on the screen now, a mechanic. A mechanic has certain information associated with it. It has a unique identifier, a mechanic number. There's a name, pay rate, hire date, status, and insurance, all values that we would need to collect relative to each mechanic. An instance of mechanic would be mechanic 12, mechanic 17, and each one would have its own separate values for those fields. So the rows are records, the columns are fields. So in that example you see on the screen, mechanic 12 has a value of Robert Lear for the name field. It has a value of 12 for the mechanic number, or mechanic no field. Now, that first field that you see there, mechanic number, and then the other table, it's a job number. That is what we call a unique identifier, or a primary key for that table. Now this allows us to keep each record separate and distinct from other records. So mechanic 12, anything I want to find out about mechanic 12 would be associated with that unique identifier. That way I'm not confusing data about Robert Lear with data about Jim Jones, because they have that unique identifier. Now some may think, well, why not just use their name? Well, I've seen it in my classes. I have, in the same term, had, and not the same class, but the same term, had two students with the exact same name, first, last, and middle name. They weren't even the same age. So we couldn't use a name as a unique identifier, because we would end up running the risk of having multiple records that would potentially be confused. So, with this said, we've got this primary key, the unique identifier. Now, the job number, that's a unique identifier for the job table. If there's a relationship between the two, meaning the mechanic works on a job, the mechanic is a primary key, the mechanic number is a primary key in one table, and it would be a foreign key in the other table. The job number would be the primary key in the job table. Now, these are basic database concepts, and we want to collect data, maintain reliability with our data so that it is in the correct form when we need it, it's there when we need it, and we know that the data that was input is reliable and it wasn't corrupt, mistyped, or whatever the issue may be. Okay, so we deal with DBMSs, and I gave different examples of them, database management systems. The administrator or the manager of the data is called a database administrator. Now, we use this to make sure that there's centralized control. The more people that have access to a data, or the data, I should say, the more likely we are to have issues with somebody making a mistake or modifying something that shouldn't have been modified. Okay. Now, we've got something called DML. It's data manipulation language. Now, it allows us to modify data in a database. Now, it's usually done in a structured query language. Okay. We'll talk about that a little bit later. Now, the schema is a description of the fields, tables, and any relationships between those tables. I just talked about a relationship between a mechanic table and a job table. Understanding those relationships, understanding the tables and the fields that are in the tables is vital. Now, we can connect our database to the web. We can have our database connected to local machines or across a network. In either case, we need to focus on security, efficiency, and ease of access. Regardless of whether it's standalone, local, or web-based, we want to have secure connections and limit users to only be authorized users. Okay. So we're controlling who has access. Now, a web-based data design gives us global access, ease of use. You can access it across multiple platforms. It's cost-effective. There are some security issues, and there are adaptability issues. Now, we have our web server connects to a database, and then users or clients connect to that web server, and the web server is the middleman of sorts. So let's talk about terms when it comes to data. Now, an entity, we've talked about it before. We talked about an external entity as a person, place, thing, or an event for which data is collected or maintained. A table or a file contains a set of related records that store data about a specific entity. A field is an attribute. It's a single characteristic or fact about that entity. A tuple, that's a set of related fields that describes one instance or occurrence of an entity. It's often called a record. Now, I talked about a primary key. It's a unique identifier. Now, they say a field or a combination of fields. We try to avoid a combination of fields making up a primary key. It's a single field. We've got a candidate key, any field that could serve as a primary key. A foreign key, I talked about that. It's a field that exists in a table that in another table happens to be a primary key. Now, a secondary key It's a field or combination of fields that can be used to access or retrieve records. Now, referential integrity, what that means, we've got this relationship between the mechanic and the job. One mechanic can have many jobs. And if you change the mechanic's number, it changes on the corresponding job record as well. That's enforcing referential integrity. Now, we can also say that you cannot input a mechanic number in the job table that doesn't exist in the mechanic table. So there's enforcing referential integrity, is making sure you can't have one here that's not there. Cascading updates on related fields, you modified it here, you modified it there. And then the last one in that little list is cascade delete related records. You delete one here, any of the correspondings get deleted as well. Now, an entity relationship diagram, or ERD, lists the entities that were identified during the systems analysis phase. You consider the nature of the relationships, and then you just link them. Okay. A doctor treats a patient. Okay. So we create the one-to-one relationship that exists, and it's abbreviated 1:1. I talked previously about the one-to-many relationships. One department employs many employees. One individual owns many automobiles. That's a one-to-many relationship. There are, in fact, many-to-many relationships. And that's abbreviated M:(N). And there's usually another table in between the two tables. So there would be a student table, a class table, and here it says enrolls in registration. That would end up creating a student class table for registration. Okay. So ERDs are not necessarily just the two relationships, it's how they're all linked together. Now, we've got cardinality when it comes to entity relationship diagrams, or ERDs. And we've got little symbols, so the entity is the square box, and then how it's set up as far as the relationship would have this little symbol to the right of that little box. So one makes one-to-many, one-to-one, zero-to-one, or zero-to-many. Okay. And then we see the cardinality described in these relationships here by having those lines across the connections. Now, data normalization, it's a process of creating a table that will assign specific fields or attributes to each table in the database. It's really more than that. We've got different levels of normalization. We'll have a table that's not normalized. We'll have a table that is a first normal form, second normal form, and third normal form. Let's talk about those forms. All right. Where are we? There we go. First normal form, or 1NF, it does not contain a repeating group. It doesn't contain a repeating group, meaning there's a primary key in the table. You can't have multiple records about the same entity. That means we've got first normal form when we've got that primary key. Okay. So having the primary key makes it first normal form. Okay. We'll go to second normal form. Now, second normal form, table is in second normal form if it's first in first normal form and all fields not part of the primary key are functionally dependent on the entire primary key. Now what that means is everything aside from the primary key only exists in this table as it's related to that primary key. It's not that it's being pulled from somewhere else and tied to it. It's not hard to get from first to second. Now there's a third normal form. This one can get kind of tricky. And it's a design is in third normal form if it's in second normal form and if no non-key field is dependent on another non-key field. So let's back up here. That would mean if this product number's unique identifier, Steve widget would be dependent on this. These two things had to be dependent. This always had that next to it. Now, that's not the case. We couldn't have that and be in third normal form. Okay? So those are the rules to normalization. We'd like to try and have our data in third normal form whenever we can. Because the more normalized the data, the easier it is to query or ask questions of the data, and the more reliable we know it'll be when the time comes to derive information from it. Okay? Hop through these. Okay. Now sometimes we'll have codes that represent something else. Now you'll see it, ATL, ORD, LAX. Those codes represent another word or a name. Right? And sometimes we can use those to make things a little bit easier. Those are unique identifiers. Okay. The VIN number on a car, unique identifier. Your social security number, unique identifier. Those are codes. The first three numbers in your social security number will dictate approximately where you were born or where your social security number was issued. Okay. So we've got different tools and techniques when it comes to data. We can have not just a database, but a data warehouse that multiple entities have access to. We see it more and more today. Data mining looks for meaningful data patterns and relationships. Now, when it comes to data mining, we're seeing it happen more and more often today, where people are trying to find trends. Now, a lot of data is being collected that potentially we're not even aware data is being collected. Now, when you walk into a store and they're asked, what's your phone number, or what is your zip code, those are pieces of data. And your phone number is a unique identifier associated with you. So now they can tell that it was you that actually showed up and did business there, and they know you're their customer. Now they can market you. There's enough data out on the internet to where they can go buy databases or big bulk records and go through and mine that data to say, all right, I'm going to create a relationship between that information I acquired from you, your phone number, and oh, here, that piece of information is over here. Now I've got more information about you. All right. So databases that consist of links tables that form an overall data structure. We dealt with different database management systems, or the options to use different ones. And we've got the difference between a primary key, candidate key, foreign key, and secondary keys. What an entity is, what an entity relationship diagram is, how to normalize a database, what a code is. Taking leaps and bounds to get ahead in this chapter. You're getting more and more. When it comes to databases, it's worth the time to go out and get as much information as you can relative to data normalization and how databases work. Get some hands-on. If you didn't get the exposure in CGS 1100 or in a database class, spend some time playing with a database. All right, there's enough resources out there to where those resources, those tools are there.